Hi there, folks, and welcome to the explanation for your last chemistry homework. Woohoo! This is homework 3 in Unit 8 talking about moles. Today we're going to be converting between moles and atoms or moles and molecules. So remember, we are going to be using a calculator for these problems. Remember, there's a link to your calculator here, so you can use the same calculator that I'm using in case you don't have one at home. So in the last one, we figured out how much 1 mole weighs in grams, but what if we don't exactly have 1 mole? For example, if we have 1 dozen of things, then we have 12 things. And if we have 3 dozen, then we have 36 things. You probably could do that in your head, right? You took 1 dozen, and a dozen means 12, and you multiplied it by 3 to get 3 dozen, right? 12 times 3 equals 36. Piece of cake. Because mole and dozen are both words that mean numbers, we can also take a mole, right? 6.02 times 10 to the 23rd things. And if we want 3 moles, then we just take that number, 6.02 times 10 to the 23rd, and multiply it by 3. It's a little bit different putting this into a calculator, so I'm going to show you how. You may be using the e function on your calculator, the exponent. So I put in 6.02, and then the times 10 to the 23rd, because we don't want to use this times button, we want to use the exponent button. This EE button on your regular calculator that we've been using, this is the times 10 to the key. So 6.02 times 10 to the 23rd, right? That's what it looks like in our calculator. So 6.02 times 10 to the 23rd, if we have 3 of them, then just like a dozen, we multiply by 3 and we get 1.806. This E is our exponent times 10 to the 24th. So I'm going to write this down as 1.8 times 10 to the 24th. Now remember, you can put that 24 into a superscript just like that. Okay, so 3 moles is 1.8 times 10 to the 24th things, whatever those things are, right? So we've been calling atoms and molecules particles earlier this year. So let's find out how many particles are in 12.5 moles. So this is sort of we're going to take this mole number. If we, instead of having 3 moles now, we want 12.5 moles. So we're going to take the number that is moles, 6.02 times 10 to the 23rd. And if it's easier to put this in like this, E23, this means the same thing here. 6.02 times 10 to the 23rd times 10 to the 23rd. And then we're multiplying it by 12.5 because we want 12.5 moles. 6.02 times 10 to the 23rd. I'm going to put that into superscripts. Okay, equals. All right, how do we do this? I'm going to clear my calculator. 6.02 times 10 to the, remember this exponent key, times 10 to the 23rd, and we want 12.5 of them, times 12.5, and we get 7.525 times 10 to the 24th. So I'm going to copy this number. And to translate this out of calculator speak, this means 7.5 times 10 to the 24th. Remember, I'm going to put that in superscripts. Okay. Remember, your calculator might have E as the exponent. By hand, it's written by 10 raised to the power of something, right? 10 to the 24th, right? It might be EXP on your calculator, or on our little calculators, it might be EE or 10 to the X power. So it just depends on what your calculator looks like. It might be easier to set up these problems using a table. We can insert a table here. Okay, so this means that we have 6.02 times 10 to the 23rd particles in 1 mole. So I'm setting this up like a fraction, right? 6.02 times 10 to the 23rd. These are particles in 1 mole. And I'm multiplying this by 12.5 moles. Okay, so I'm getting units, 6. All of these are particles. So these are set up like fractions. So there are this many particles in 1 mole, just like we can say that 12 inches are in 1 foot. We can put those numbers over each other and turn it into a fraction. 6.02 times 10 to the 23rd particles in 1 mole. And if we multiply by 12.5 moles, this moles and this moles cancel out. So it's just like multiplying across the top and dividing across the bottom. So we have 6.02 times 10 to the 23rd. Oops, I want all of these to be. There we go. Now I've got 6.02 times 10 to the 23rd particles in 1 mole, and I'm multiplying by 12.5 moles. All these to be italics and regular size. Okay, when I put it in a table format, I have particles per mole and moles on top. This is over 1, so I'm setting this up like a fraction. My moles and my moles are across from each other. I multiply if I see the numbers in the top, and I divide by numbers that I see in the bottom. But because both of those numbers on the bottom are 1s, I just take 6.02 times 10 to the 23rd times 12.5, and I got the number that I had up there, 7.5 times 10 to the 24th particles. 10 to the 24th particles. Okay, let's try again. A second example. How many atoms are in 5.2 moles? So we know that in 1 mole, there are 6.02 times 10 to the 23rd atoms in 1 mole. But because I want 5.2 moles, I multiply by 5.2 moles. And this, to turn this into a fraction, over 1. Now my moles are in the top and in the bottom, so they cancel out. So I just take 6.02 times 10 to the 23rd, and I multiply by 5.2. And I get 3.1 times 10 to the 24th. This is what my calculator spits out, but I can translate this. Into real speak. 3.1 times 10 to the 24th atoms, and make that small. Okay, remember, you can make it small by going to Format, Text, Superscript. All right. But what if you know how many particles you have and you want to calculate how many moles? Then you can turn the particles into moles by sort of doing this backwards. So if we have 3.5 times 10 to the 15th particles, I know that I want the particles to cancel out. So I want moles to be the units that I get at the end. So I put moles on the top. And underneath is where I'm going to put my 6.02 times 10 to the 23rd. Because now I have particles on the top and particles on the bottom. And the 6.02 times 10 to the 23rd always has to go next to the particles, so that the particles and the particles cancel out, and then they got moles in the top. So I have 3.5 times 10 to the 15th particles times 1 divided by 6.02 times 10 to the 23rd. That's how fractions work. Remember, we multiply across the top and divide across the bottom. So 3.5 times 10 to the 15th particles times 1 divided by 6.02 times 10 to the 23rd. And I get 5.8 times 10 to the minus 9th. This is a smaller number. 5.8 times 10 to the minus 9th. I'm going to round this also. I'm rounding this to 5.8 times 10 to the minus 9th. And my units are moles. This means that we don't even have 1 mole. We have a tiny, tiny, tiny amount. So if you're trying to go from particles to moles, you divide by particles. If you're trying to go from moles to particles, then you're multiplying by 6.02 times 10 to the 23rd. So remember, putting something in the denominator means that you're dividing. So 3.5 times 10 to the 15th divided by that many particles. What if we have 10,000 particles? How many moles is that? So remember, we can take 10,000 particles, and I know that I want to make the particles go away, so I'm going to put moles in the top and put my 6.02 times 10 to the 23rd particles in the bottom. So I take my particles, divide by 6.02 times 10 to the 23rd. Let's see what we get. So 10,000 times 1 divided by 6.02 times 10 to the 23rd. And we get 1.66 times 10 to the minus 20. 1.66 times 10 to the minus 20. And I can write that in regular times 10 to the minus 20. Remember, if I want to make it an exponent, format, text, superscript, and these are moles. Again, a really, really small number because this is less than 1 mole. Way, 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 way smaller than a mole of particles because a mole is 6.02 hexillion particles. So many. I know this is confusing. I'm asking you to do a hard thing for your last thing, but hopefully the mole day video will make up for it. If you haven't seen it, go back and watch me be silly. I miss you all. You've got 1, 2, 3, 4 problems, just 4 problems to try for this, and then you'll be done, totally done, all the way done. Good luck, everybody.